Hey everyone, how are you doing? Hope you've had a good day and are ready for another session in AP Human Geography. I'm Ann Lindsley from Bel Air High School in Houston, Texas, and we are going to look at data analysis today in the AP Human Geography classroom. So let me share my screen with you and we will get started. And here we go. There should be coming along. There we go. All righty. So once again, AP Human Geography. And if you want to ask us questions live, you can sign on to our slido.com room at 7807. We will try to answer any questions live during the presentation, but if I'm talking, that means I'm not answering them. So do post what you want to, as long as it's topical, please. Let's stay topical. That way it helps to get people's answers done. And we will get into this presentation and then answer some of your questions as we get along. So first thing I want to do is to begin with the questions that I proposed to you yesterday for FRQ review for our exam that's coming up. And in particular, I wanted to point out to you that, again, this is a question that is blending agriculture and industrial location. So this is a blended topic, and it's a really good example of a blended topic. And we have some more that we're going to show you as well. So those of you who have sent me separate emails questioning why we aren't doing chapter 6 and 7 or unit 6 and 7 when we already done them, or that you absolutely are 100% certain you don't have to know them, I really need to dispel that idea, because this is a classic example of how material from unit 7, in this case, the sector models of, or not sector models, but the sectors of the economy actually correspond back into the agricultural section, which is unit 5. So please be careful with that mindset. That's why Ms. Brandt and I really carefully went over all those topics in unit 6 and 7, so you could draw upon them to answer these questions. And so let's look at this question. Hopefully you had a chance to look over it. And here we want to use an example of a specific industry other than one that is portrayed, which would be ethanol, and explain under what conditions an industry would be located near the market. So this is drawing upon your understanding of Weber's least cost theory. And here's a little skill advice when looking at FRQs. So I couldn't remember the name of that, but if I read all the way through the questions before I started writing, there's the statement. There is the name of the theory right there. So do yourself a favor, take a big deep breath before you start to write. Okay, my mom always said do that because I would have stress test anxiety. So look at through all of the questions, because maybe Weber's least cost theory didn't pop to my head right here, but then, oh yeah, there it is. And so now I know what I'm doing. So, okay, so explain under what conditions an industry would be located near the market. So, oh, did I skip under 148 on the map? Okay, be located near the market. So if I am locating an industry near the market, obviously this isn't going to be the market because you have your understanding of where your largest cities are. So your market's going to be over here or over towards Chicago or down south where your largest market is. So why would I put a specific industry near the market? Because it's going to be a bulk gaining industry. It's going to be something that we have to add raw materials to in order to get a new product. So it's either going to be weight or actual physical size. So for example, soft drink bottling companies or bread products, actually any bakery products would be located near the markets where you're bringing the raw materials together. All right. Next question is asking me to provide an example of a specific industry other than the one portrayed, to explain under what conditions an industry would be located near the raw materials. So hopefully that comes to mind, that this type of an industry would be one that we have to take the raw materials apart. So bulk reducing, a bulk reducing industry where we have to break apart what we actually want from that product that we are extracting from the ground or from mining operations. And so exactly that, mining operations are a perfect example of bulk reducing, where we have to get the ore out of all of the overburden, or gang as the material is referred to. It's all the extra, the dirt, you might want to call it that. It's really not dirt, but anyway, but you want to break the ore out of that. So iron, copper smelting, iron smelting, also lumber products. Lumber mills would be located away from, over near the forest and not near the market. All right, so now we're going to use using the map and Weberian theory, we're going to explain the geography of ethanol plants in the United States. So why are these ethanol plants located where they are? Because what is the main component of ethanol? And it is corn. So corn is what is bulky, and we're only using part of the plants that will go into actually manufacturing the ethanol. So the ethanol is located where the corn is, because we are breaking down the corn and using that then to produce ethanol. And so that is why it's going to be located here in the upper Midwest. This was a very good question when we had it. This was also a good lesson that I use when I'm working with teachers and students face to face a lot of times, because this is an exercise in reading everything that's on the map, and we can't stress that enough. And I'm going to say that a couple of times with this particular presentation as well. This map tells you this is ethanol manufacturing plants, and then it tells you existing plants and plants under development. When we talk about plants growing in the field, we don't talk about plants under development. We talk about acres of plants or cultivation of plants. We don't talk about plants under development. We had some confusion when this question came out, that students thought that ethanol manufacturing plants were actually plants that grew in the ground. And as funny as that is, it's also kind of sad, because that means they didn't read manufacturing and they didn't read the legend. So just as a forewarn. Least cost theory is, we explained that in the 2 topics in Unit 7. So I encourage you to go back and look at that. But least cost theory is dealing with where a location of a manufacturing plant. Do we either build that plant near the source of raw materials, or do we build it closer to the market? And what is going to be the determining factor there is if the cost of transportation or the cost of breaking that material down and then shipping it is greater. So if we, as example here, once again, corn has to be taken apart to extract the parts of the corn that we need for making ethanol. Corn is bulky, corn weighs a lot, there's a lot of waste to it. We don't want to transport what we're going to waste. We're not going to transport what we're getting rid of. So we are going to have the ethanol plant, the processing plant, the production plant near where we grow the corn. So this is why this region, Iowa, Nebraska, Minnesota, South Dakota, not only has all of these ethanol plants, but it also has all of this corn. So the corn is there, then we build the ethanol plants. Same thing with animal processing plants. Animal processing plants are no longer in the market. We don't have livestock walking to your big cities to be slaughtered. That we left that in the early 1900s with the cattle drives, late 1800s. So your cattle slaughter operations are out where, in the areas near where the cattle are, to reduce the cost of the transportation of live cattle to slaughter. And let's not talk about that anymore. Anyway, so least cost theory, the determinant is going to be the cost of transportation of the material that is going to be manufactured. I want to either break it down if it weighs a whole lot, where it's near where its source is, or I'm adding to it and that product is going to be bulkier. So if I'm going to add to it, I want to be closer to my market. So then I just bring in all my raw materials. So if I was going to make bread, I have to bring in the wheat, I have to bring in the flour, or I have to bring in, the wheat flour, sorry, the water, the sugar, all of that kind of stuff that goes into bread products. Okay, I did not forget D, no worries. This question, part D, is asking you to explain one impact of empowering women within the rural agricultural regions of developing countries. So not only do we need to understand developing countries, we have to understand, I just explained Weberian theory. We have to understand developing countries, but also the role of women in developing countries, in particular in agriculture. And so I mentioned yesterday, or in the agriculture one, I can't remember which, the role of women is one that most of them in the least developed countries are engaged in subsistence agriculture. So when we look at what is their role, why are so many involved in that, part of that we have to examine is what is impacting them. And so we begin to see there's laws that prevent them from owning land. They are not allowed to work in certain types of industries because there's men that want those jobs. They care for a large number of children, so that becomes a factor. They can't be away from things that would take them away from taking care of those children. They can't read or write in some cases, so their skills are limited by that. There's a variety of other factors as well, but those are some of the main ones that we'd start with. Okay, so a question came in: what was Weberian theory and what is least cost? Least cost theory is Weber's theory. Weber is the author of the least cost theory. Those are the same. Okay, so once again, remind you, I'm going to do this every day because I had someone who sent me an email and asked me when the AP exam was. So yeah, May 12th, once again, and we are looking at describe, explain, and we're looking at relationships. We're applying all these different things that I've been explaining to you about in context, okay? Notice there's nowhere here where it says memorize all the vocabulary words, all right? So once again, make sure you go down to apcoronavirusupdates.collegeboards.org and /students. This is going to be your latest and greatest information that tells you all about what's on the exam and also gives you the most up-to-date information about getting connected and making sure you are ready to go, as well as the emails that College Board has sent out, as hopefully your teacher is also in touch with you. All right, so today's topic. Today's topic is looking at the skill of data analysis. So just like yesterday, I took you through the different spatial relationship topics that are within the course. Today, I want to take you through specifically looking at some of these topics in terms of data analysis. What are we doing with the data? So geography in general is a spatial course. And spatial meaning that what takes up particular places, what functions in those places. All of that is data. So the foundation of our spatial study is actually data and what we do with that data and how we interpret that data. So some things that I want to point out and caution you about, as well as address as review topics. So when we're looking at data analysis, this is what it's telling us. We're analyzing and interpreting quantitative geographic data as it is represented in maps, tables, charts, graphs, satellite images, and infographics. Okay, infographics. I love infographics. All right. So once again, task verbs. You are going to dream about task verbs. All right. So our task verbs: describe, explain, compare are the ones that you're going to be expected to address on the exam. In this particular study of data analysis, we are seeing describe and explain as the types of task verbs that we would have. Once again, describing is just tell me what is there. What do you see? You know, what do you see? And just don't say it's a graph. What is it a graph of? Okay, it's not asking why. What is it a graph of? Explain to me what you are seeing. Pretend like your reader cannot see what you are looking at, and you are determined to show them exactly what you are looking at, and they cannot see it. Okay. Explain. Explain is a detailed account, giving reasons. So once again, like I said yesterday, tell me what, tell me why, and then because. What, why, because. Why does this relationship exist? Because what is going on, okay? And then compare, we will get to compare when we have those come up. All right, so once again, all of our skills have incremental levels that they go through. So data analysis begins with just the very beginning of identify, and then it goes through the describe and the explain And oh, we do have a compare. Yes, a compare, and then explain what it implies or what it links to in terms of geographic principles or processes. Look at this very last one. Explain possible limitation of the data provided. There are very few of our skill levels to get to this, but we definitely want to pay attention to this, particularly if you've never had a stats class. If you've never had any statistics and you just look at a map and it's a lot of pretty colors, and you've never asked what is going on, or if you've never played the skeptic, you have to be able to look at this data and say, okay, well, how is this skewed? And if you don't ask those questions, you aren't going to begin to be able to see these limitations. So with that being said, let's skip to our first one. All right, a graph. Isn't that awesome? Look at those pretty lines. Great. Is that telling me any kind of spatial information here? No, it's a graph with different lines. Oh, and look, I got the countries labeled too. Okay, well, obviously the world is higher than the rest and the United States is higher than those. All right, well, to start this with, because I'm looking at the introduction of maps, which is part of the very first unit. And the first unit is how we think about geography in the first place. So I just picked a very current topic. This is yesterday's global fatality report on the COVID-19 virus. Okay, there's the date right there. I told you I took this fresh and live just last night. So this graph is great. Okay, I can read this graph. It says clearly United States is highest and the world is even higher, da, 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 da. Or I can look at it in a list. Oh, wow. Okay. Now, what happens when I look at it on a map? When I look at it on a map, I'm now able to interpret this a little bit differently. I am looking at this to identify different types of data presented on maps. Okay, so I am just looking at quantitative data on the map. But now when I look at this, instead of like a graph or a chart, I now am looking at to see if there's any spatial connections. Well, looks like the continent of looks like sub-Saharan Africa is not having as big of a problem. I might want to conclude here. But then I need to be the skeptic and ask, well, is that entirely true if all the rest of the countries are more of a hot Valentine pink, falling into this middle range here? Or what else is going on in sub-Saharan Africa? Why is that number so much different in terms of looking at the rest of the world's distribution? Well, maybe they haven't tested it as many, or that they have, or it has arrived at a different time, and so not as many have died of it yet. I can also look at quantitative data at different levels of scale. This isn't really telling us anything that the other map didn't, because it's not down to the smaller state or county scale. All right, so now I also want to look at how maps are giving me information that based upon the type of the map. So this is a reference map, and a reference map is going to show me location of different types of data. It's going to show me boundaries and names, unique identifiers, things like this. So I've got the boundaries of the United States, the state's abbreviations. So now I want to continue looking to see how far down I can go. So I can obviously go to the state level. I see the state, I see some major cities, I see some major highways, and then I can go down even further. Of course, I was going to use Houston. Well, I'm not going to use something I'm not familiar with. All right, so now I can look at Houston. I see our circular 3 major beltways. I see our roads. I see a big star. It must be something at that star. So now I'm looking at the entire distribution of Houston. Once again, I see more patterns, more colors. I am still looking at a reference map. I have some scale that now appears on the bottom of my map that I desperately need to have. I am also showing distribution of physical features. Now I'm looking even closer. Now I have a section of Houston. I have a section inside of Houston actually called the city of Bel Air. And this is where I am broadcasting from right now. And so I'm looking at, well, this star and what is going to be at this star. I am still looking at boundaries. These are boundaries for the city of Bel Air in the middle of central Houston. And I keep on going, oh, that star is the construction zone called my high school. And so I'm looking to see, well, what is there? So I can now go even closer because images become part of our study. That's what the high school looks like that they're tearing down so that they can build this. Okay, I know some of you are wondering, why are we tearing that down? That's a long story for a different day. Point is that we started with a reference map. and we moved all the way down to get to the exact point that we were trying to get to, okay? We also can look at patterns with maps, and patterns are important for showing us different types of connections between places or where points are. So when we look at patterns, we can look at point patterns, we can look at line patterns, and we can look at area patterns. So if we look at this map of the world at night, we can probably pick out the cities. You can pick out the outlines of the continents. Can you pick out what lines might be? What are some of these lines that we see? Are these lines small villages? Are these lines reflection in space? Are these lines ships out in the ocean? We see lines, and we also see point patterns of anything that has a light on it or is reflecting even out in the ocean. So we see lines, could be highways, rail lines. Usually highways will have lights on them. And you can pick out, here is, where am I at? Here is I-10 going across the southern United States, okay? You could probably pick out some of your others. I'd be wrong if I told you them because I don't have them all memorized. Then we also look at area patterns. We have these vast areas where there aren't any lights. Well, that's at this level of scale. Maybe if we were able to get closer and closer, there would be lights there, okay? So just another image of how we are dealing with data on a map. Remember, the absence of lights in these doesn't mean that there isn't a pattern there. The absence of light is a pattern. All right, so in looking at some other ways that we look at data, we look at data in terms of clustering and dispersal of preferences. So for example here, these two very popular maps that you can find on the internet, we look at the clustering where data is grouped together in a particular place. We look at the clustering and we can see, hey, look at what it is by soft drinks. What do clusters of population, in this case regional clusters, call different soft drinks? Okay, and we definitely begin to have an interesting pattern that almost becomes part of our vernacular language. Then we also can see how a particular product is dispersed over places. So in the case of Starbucks, how do we see a global dispersion? I can look at a local dispersion, and then I can look at a regional and a global dispersion. Have you ever done that? Have you ever driven through small towns and then all the fast food restaurants are all clustered in the same portion of town? Is maybe right near the bypass where you can exit off the highway. Why would they all be located there? Remember, you always want to ask why. That's the only way you're going to get down in understanding a map. Why do you have those patterns? So why do we have, first of all, what kind of pattern do we have for the Starbucks? And then why do we have this pattern? Is South America doesn't drink Starbucks? There's no Starbucks in Africa at all? What about in India? I'm willing to bet there are Starbucks there, but the problem is the scale of the map is not showing as many of them as you would see in other parts. There are no Starbucks in Iceland. Can tell you that. All right, same thing with McDonald's. Application of it. All right, so one of the things to keep in mind when we look at places is how something is dispersed, or if it's in a straight line, which is linear, or if it's nucleated, meaning it's all together, okay? So hold on, this slide's gonna take a second. All right, so we also use data to look at elevation. And you are not gonna have a contour map, don't worry, but I wanted to show you a contour map is the way we used to, well, it's one of the ways that we show elevation data on a flat map. And here we're using lines to represent so many feet, usually it's 5 feet of elevation as you keep going up. But your eye begins to be trained once you work with these long enough that you can actually see, oh, this mountain is actually rising. This is rising up because I can see the contour lines are so close together. Data is collected and then mapped in this format to show elevation. You're probably more familiar with looking at elevation in terms of graduated color or shaded elevation, which is exactly what this is doing. This is shaded elevation. So from the Gulf Coast to the high plains, all the way over here in West Texas. So we come all the way from the Gulf Coast into the coastal plain and into the area known as, oh my gosh, this is the prairie areas and central Texas, and then we gradually continue going on up the staircase all the way into West Texas. The hill, I'm sorry, this is the hill country. It's carved out by some of the rivers. Okay, my Texas friends, just calm down. All right, so we also look at maps because of the distortion that maps have, and this is still all part of Unit 1. This is a big topic here with maps, and we have to consider, depending upon the information we're looking at, is there distortion, and what does that distortion do to my interpretation of that data? It does have an effect on how you perceive the size of places and the arrangement of places and the distance between places. But if you are just depicting data on there, particularly human data, and you're not using it for measurements and things like that, if you remember that there's issues of distortion and you're just looking for patterns of data, the distortion is not going to interfere too much with your interpretation. But you do need to recognize that maps have this distortion, which does alter our complete understanding of the true representation of that particular place on the planet. All right, so if we move also further down into this particular unit, what kinds of data do we collect? Well, when we're dealing with human data, the best type I prefer is to get it from the Census Department. I love the census, and the 2000 census was just a wealth of data for geographers. And then the 2010 was kind of disappointing. So I'm excited about the 2020 because there's some more of the questions that they put in. But the data that we can get for the census from the census starts to allow us to see certain types of patterns. For example, average family size. Now, what would I want to do with this? Besides, I love to see patterns and I love data, and it drives my students nuts, I'm sure. But this is just, it's droolable. Oh my gosh, it's awesome. But what does this tell me? This tells me that if I'm down here in this region of Texas, or I'm over here in this area of the West, well, for one, I need to consider how big these counties are and what the population is, because those are huge compared to these areas, and particularly out here. But I still have a significant pattern that the average family size out here is running from 3.13 to 4.74 people. So, anyway, keep in mind that that's an average. So, but that means that I have to potentially address these needs. If these have a large families, then aren't they going to need schools? Aren't they going to need certain types of businesses that cater to people who have a lot of children, versus areas here in the upper Midwest that have less than 2.86? That means they don't have very many kids. And if they don't have very many students, then what is that doing to their school systems? And maybe some of you are in those areas and definitely know that there's not a lot of kids in some of your schools, and schools are being consolidated with other towns, and your commuting distance is awful in a lot of cases. So this is what this kind of data tells me. It's showing me patterns. Would I want to use this to plan for a particular site, for a particular town? No, I need to get more and more specific. So those are things that I would want to consider. Now we're going to move into the next unit, which is population and migration, and look at how data impacts some of our interpretation. So using the topic of population change and what we see with natural increase and doubling time and growth rates, we begin to process data at a different level of scale. We're looking at this global scale, and we have to begin to ask, well, how could this might not be totally correct? Well, we're looking at national levels, the whole world as a whole. And so we're not looking at what is going on in regions of the country or certain towns and cities in the country. That's not being divided up here. And so that's one of the limitations of our data. Still, it's giving us an interesting patterns. And so that if we look at in terms of population growth, so the previous one was looking at population change. So where are we going to have increased population change? It's going to be sub-Saharan Africa and some spots in South and West Asia. If we look at projected population growth, we're starting to get a little bit different pattern. We're picking up some areas in South America. We're picking up more areas here in West and South Asia of where we are looking at population growth in this region in a 30-year period of time. And then when we look at fertility rates, shouldn't there be a relationship between population growth and fertility rates? If we have higher growth, we're going to have higher fertility rates, right? So what is interesting is, I know what the next slide is, but what is interesting is look at this region here, South and West Asia, and then Africa. Okay, keep your eye fixed on this, because this has become relatively closer to 2.1 to some degree. I mean, your highest here is 2.5 to 3, so they've definitely reduced in the last 30 years. But pay attention to this group when I show you this next one. All right, so this is 1970. This top is 1970. I'm looking at patterns of change of data over time. I've added another component, change over time. If I'm looking at 1970 and now I'm looking at 2017, look at this, y'all. Look at the areas that are purple here in 1970 when the United Nations and other programs started to address development and linking fertility and large families to development issues. Look where we are now today. Now, these are still huge populations, don't get me wrong. They are still huge populations. They're living longer, so you have this population momentum also as a factor. But we have fewer, our fertility rate in a lot of these countries has declined significantly, such that they've been able to better manage their growth. That's what I'm getting out of looking at these. Why is Africa so high? Good question. I love that kind of a question, because now we're thinking, well, look at Africa in 1970. Look at Africa in 2017. I would turn that question around and say, wow, look at the progress that sub-Saharan Africa has made. Why is Africa still so high? Because high fertility rates are tied to lower economic development. We have a lot of children because of fear, for a variety of reasons, fear that you're not going to have a child survive into adulthood. You need them to help with domestic and farming levels. You in some cases, very strong Catholic countries, one needs to go serve the church. The girls get married off. You don't have them in some cultures. So there's all, and then you have mortality rates for children, infants and children, flus and diseases, things that in the developed world are more resolved early on through vaccination. So that's actually what's happened here, is that they've brought healthcare to less developed areas of the world, vaccines, better quality of water, access to medical care, access to sanitation. That is what has changed the mortality rate. And when you change the mortality rate, then people don't have so many children, because they don't need to have as many, because they have the confidence to know that their children are going to make it to adulthood and become the Social Security policy that they wanted them to become. Okay, I hope that long explanation to answer your question, but it's one of my favorite topics. All right, so if we now look at mortality rates, and we look at mortality rates, the top one is both sexes. We're looking at data, plotted data. So we have both, oh my gosh. Then we have large numbers of child mortalities, and then we have female mortality itself. Do we see anything here that is going to be interesting patterns or different kinds of patterns? Well, we have very low under 5 mortality in the northern worlds, in the developed countries, but we also have low mortality in countries that have less density and are not in your mid tropic areas where you're subject to tropical types of diseases. Okay. All right, so let's go on. Migration topics are also a factor in this particular topic. And how do we begin to look at migration? Instead of looking at a chart, this means a lot more. I hope you're seeing this. This means a lot more, because now I'm looking at chain migration from one place to another. I'm looking at migration flows. So I'm taking this data and I'm plotting in from the directions that it's going, where's it going, what are main routes of migration. And the significance of this in terms of looking at these is that these migration flows allow these countries to better plan, not just when the people show up at the door or at the border. Now we're able to plan if we see these chains of migration happening. And so anyway, this is a great visual for this. And so, all right, so our next one is dealing with some of y'all's favorite topic. I've been asked this by a couple of students, the demographic transition model. This whole thing is nothing but data, y'all. It's glorious data. Oh my gosh. If you spent only 10 minutes looking at this, you didn't spend any time in class looking at the data. Look at all this beautiful data, all these numbers. Yes, I did love math in school. I know that's hard. But anyway, all of this data comes into play to then be able to interpret what is going on. How do we take all of this and figure out, well, what countries fall into which one of these stages? How do we still get a rising population in the third stage and our birth rates are dropping? Well, that's population momentum. Well, what does that mean? That means people are living longer. There's data. How long are they living? Well, maybe 45 years, maybe 65 years, maybe now up to 80. How about in Japan, where you have 1 million people over the age of 100? So that this is becoming a factor here. So they are living longer. So your population is expanding. They're having fewer children, but your population is still expanding because they're living longer. So what is happening? Well, fewer people are dying. That's the answer here. Fewer people are dying. And that, again, is a death rate. So we've got birth rates, death rates, we have growth rates, we have life expectancy, which has to be implied through understanding why the population is expanding. How does that all happen? Well, access to education, economic development. Economic development is a catch-all for improved infrastructure, improved sanitation, employment, less business type stresses. And oh my gosh, this is a model. This is a model. It was built upon England, but here's 5 other countries and their demographic transition model over time. This is on Our World in Data. So if you love the DTM and love all this data, you should have Our World in Data bookmarked for yourself. It's a glorious place for the numbers and data and showing all this great stuff. The whole point here is that you need to realize that all this data has to come in here to be able to interpret this model. However, it's a model, and like any model and any set of data that we are putting into a different dimension and mixing a lot of different data with it, it has limitations. And one of the limitations of this particular model that is essential today is that it doesn't take into consideration migration. It does not consider migration, and it also does not consider regional development within a particular country. And it also doesn't take into account very rapid or quick fixes to birth rates and death rates. And so there are some limitations, but it's beautiful data. All right, so we continue looking at data. Let's look at the political unit. In the political processes, we look at where places are, why they begin to fall apart. We talked about this the other day. And we looked at what causes island nations to have devolutionary factors. Well, what's the data showing me? The data is showing me that we have all of these islands here, and these islands are going to have different situations arise that allow for ethnic populations or lack of ability to rule certain areas. It's going to get out of hand, and if we don't know what's going on, then we could have some threats to our sovereignty of our state. But most importantly, if we keep track of where certain groups are doing certain things and patterns like this, we begin to see that there's clustering or there's dispersal of within different parts of the country for different types of discontent, and countries can then respond to it. And it's tougher when you are, I'm going to use this word, some of you are not going to like it, this tougher when you are a fragmented state. Okay, that's an island nation. Okay, all right. So some of the things that we could keep track of, rise of terrorism, political violence. Look over here with Indonesia, also with Japan. These are dealing with a large number of islands where certain things could happen and it could put the whole country at risk. Now, limitation of this data, this is at the country level. This is not at the regional level within a country. And so it doesn't give you the accurate portrayal that you would need of, say, Malaysia and Indonesia and Japan of 2,000 islands. And so even the United States, we have some fractional issues that are going on in some more remote areas. And it doesn't reflect when you see it at the country level. So next I could look at genocides. This is all part of this political unit. What patterns do I have for genocides and ethnic cleansing? And so then I'd have to go in here and ask my why, and my why is going to be followed with my because. And so I can look at this area right here in the Middle East and start answering some of those. Well, there's a war in Syria, there was a war in Iraq, and we've got some other uprisings in Algeria. So what's going on in China? We need to look at those. Okay. All right. So I got to go faster. So I can now look at a country level and I can see this is where I start to have a pattern. So if I'm starting to have a pattern of ethnic conflict that could result in a threat to my sovereignty, I now can see that. I'm mapping that data of where these are. Data analytics is so amazing. It's one of the newest, it's a new area of study where you mix that with some geography. Oh my gosh, that's a fabulous job. All right. So once again, here's my other example of a graph that's like, okay, there's pretty lines all over it, pick up sticks and that kind of stuff. Well, this is looking at people in poverty. Okay, does it mean I need to see clustered data? I need to see dispersed data. I need to see what's going on. Well, now I'm looking at a very definite area here where I've got some clustering of extreme poverty. That means that they are living on less than $1.90 a day, and they are not able to satisfactorily feed themselves. So what does that have to do with other development factors? Well, how about poverty and life expectancy? Is there a correlation? Okay, so there is a correlation to some degree about deep poverty versus life expectancy, and less poverty, higher life expectancy. So there is a more of a correlation, but here poverty is measured on $3.10 a day. So we want to keep that in mind. But you know what? I'm still not getting a spatial perspective, even though it's colored. So here's my spatial perspective. This is a multidimensional poverty index. This means these people are so poor that it plays a role in their health, their education, their livelihood, and mortality rates. So this is what is playing here. So this multidimensional poverty index shows me more specifically, where is it the worst of the worst? Okay. So in the urban section, for those of you who are so like, I don't know what to do with the urban, we haven't had any, go back and watch the videos. All right. So in the urban section, we still are using data analysis to look at cities and urban land use patterns. So, okay, so a hodgepodge of colors. No, actually, this is great data. This is telling me what is going on in this particular city, which is London. Where are places? What type of pattern do we have of different types of structures? What is going on? I want to look at this more clearly. I want to see how I can see trends in this particular city and in this particular area. So I can zoom in on this particular area here, and I can start seeing more patterns in terms of land use. And so I'm going to go from here, right here, to right here. Okay. What's going on? Is this residential? Is it commercial? How is it all happening? So now I'm going to look, I'm looking here, I pulled up my Google map. I got to get closer and closer. So I'm looking at where there are connections. Where are we sitting in terms of the Thames River? I'm going to get closer. I'm still looking at this particular area right here. Right here, I can start to read some of the toponyms. But now I'm going to get even closer and get a better idea of exactly how these folks are using the land right in this area. Okay. So now I'm going to get closer. Oh, look, lots of green space. Maybe not what you pictured right on the banks of the Thames River. Look at this. And that was actually water. When we looked back here further, couldn't really tell that that was water. Can't really, okay, that gives me an image right there, but it's like, not really sure what's going on here. But now when I get closer and closer, the data is revealing exactly what is in this place. And I get closer, nice marina right there next to a big fancy, oh, Tower of London. Notice everything in London is closed on the map. So this is the Tower of London, green space, everything, the main highway. I want to get closer. And now this is what I'm looking at. So by looking at urban data, where places are and what's around them, I now can understand better how density of a city is, how density may play into, say, for example, expansion of viruses, how people live, how they work, how they function, what needs to happen. There's a cruise ship, and what a city looks like. So here we have where the old meets the new, the modern architecture with the old traditional architecture of Tower Bridge. All right, so in the last unit, which is on development, this is where we start to hit this particular type of analysis that has to be done in terms of explain the possible limitation of the data provided. I've been talking about that on some of these, but specifically here, we want to look at what is skewing our perception of this data. Now, we still see a pattern. I give you that. We see a pattern. But in this particular type of data, we're looking at GDP per capita. And okay, we're looking at the GDP per capita. And what this is showing me is that it's too simplistic. It doesn't account for personal distribution of income of the people, but yet it's called per capita. And so people tend to interpret this to mean that's what everyone in the country makes, but that's not true. This is the national wealth of the country, not the implied personal wealth. And that is a problem with the type of data and the way it is presented. The next, dealing with the HDI. And HDI is one of the ones that everyone memorizes, you know, life expectancy, knowledge, decent standard of living, all of that. And that's great, but we begin to have similar problems here. And HDI, let me go past that. When we start to look at HDI, we look at the problems with it. It's not comprehensive. We're looking at multiple variables that are coming in to give us this index. It doesn't measure short-term development, meaning that it's measuring things over a very, very long period of time. And it's not looking at what happens if you have a short-term burst of economic contributions to the economy. What happens if you come in and start schools all up? Things like this that contribute to the HDI variables, but it's short-term initially. It's not going to show up in your HDI. Additionally, the data is complex. There's all these different types of data and it's complex. And then income isn't even calculated in here. And we're talking about human development. Income, a personal income, is going to be a separate variable that needs to be considered, but it's not. HDI stands for the Human Development Index. This is a means of measuring population development of a country based upon your life expectancy, your levels of education, and your standard of living. All of these are factors that are part of the population unit and how we look at development. Once again, it was in the stuff that we covered in the videos for Unit 7. So if you didn't see those and you didn't think you need to be responsible for Unit 7 at all, please go back and look at those so there's no surprises for you. All right, so let me go on, and we are getting close to time, so I'm going to go on past this. But so we've looked at the different types of data that is presented in maps. We have to describe spatial patterns using that data. We have to explain it to come up with conclusions. That's the why because concept. We're comparing two different kinds of maps. Do we see trends? Do we see trends over time? How do we illustrate certain processes? How do we begin to see how data is going to change a place or is reflective of change? And then lastly, what are those limitations? And ultimately, why, what, because, okay? Now, questions to practice. And you may have to go back and look at these on the video because I've actually given you 2 of them because I couldn't make a decision today. All right, so in this particular question, it's giving you a visual stimulus of population statistics for China. So I want you to go through and look at the data shown in the table and calculate the natural. You're not going to need to do this for the AP exam, so if you skip that part, we can live with that. But it would ask you to calculate the rate of natural increase, birth rates minus death rates. All right, describe total fertility rate. What does that mean? What does that represent here? And looking at the natural increase rate, describe how to calculate the doubling time of India's population. Should have had that in the population unit you had. And then ultimately explain how China's population statistics are unusual for a country with an economy that is still in the process of industrializing. So think about this. This all comes from the data of the population unit. And there's also another question, and I'm going to let you go back and look at this because this deals with Unit 1 and looking at basic map representation from Unit 1. It's a pretty good question. All right, so any questions? My trusty office assistant, do I have any questions that I haven't answered? I need to see them. And what are my questions? What accounts for South America's relatively high development, industrialization in Brazil, heavy manufacturing in Brazil, and also in Argentina. Argentina has a very a large immigrant population that has come in over the last 50, 75 years and brought industrialization with them, plus a very strong agricultural economy as well in Argentina. Brazil was an area, it's one of the BRIC countries, it's on the semi-periphery, and it was one of the areas that development was excellent to extend to because of lower labor costs. Why would the dairy industry also be yes, dairy is an acceptable answer into A on that question on Weber's least cost theory. Could COVID be a form of Malthusian population check? Well, in my environmental science class, we would talk about that, but we probably won't talk about that here. I don't think your mortality rate is yet high enough on the COVID because science and technology has interfered here and to prevent the mortalities. What am I looking at? Is bulk gaining and bulk reduce? What is bulk gaining and bulk reducing is part of Weber's least cost theory. I explained that in the very beginning. So if you go back, you can, bulk gaining is where you are adding to a product, and bulk reducing is where you're breaking down a natural resource to make it lighter for shipment. Are we allowed to use personal examples from our state, city, in our FRKs? You can use them, make sure they apply. It depends upon where you're at, you know. Yes. Why are there more female mortality rates higher than male mortality rates? It depends upon where you're at. In less developed countries, if there's not civil war going on, you can have higher female mortality rates, particularly of reproductive age. Female mortality in childbirth is one of the leading causes of death for women. Childbirth is not it's not an easy process in a lot of places, and I think if they taught that in health class, we would solve some problems in this country, but that's an editorial comment. What else? Is it possible for populations to go backwards in the DTM? Yes, Afghanistan has, however, there is no country in stage 1. There is no country in stage 1. There is no country in stage 1. Okay. Is there ever an exception where a business might want to be far away from the market? There are some businesses that are far away from your market. Anything that's what we call a footloose industry, telemarketers, editorial operations. My producer for this actual video is in Los Angeles. I'm in Houston. College Board is in New York City. So we don't even have to be in our markets, and you all are out there. You all are our market, and we are connecting. Oh my God, the geography is beautiful, y'all. You are connecting through technology to allow us to get the message out without having to be right there. Isn't that beautiful? Geography is everywhere. Do we ever go over Unit 1 at all? Yes, I've been this whole time. All of the map stuff was all part of Unit 1. I don't know what kind of maps or graphs will mostly be on the AP exam because they're all going to apply to the units. Maps and graphs are going to apply to the data in the units. So you need to be able to interpret them, which was the whole point of today's and yesterday's sessions, as well as the one Ms. Brandt is going to do tomorrow on the 4th skill. Do we need to memorize the distortions of each different? No, you do not need to memorize the distortions of each different projection, not at all. You need to know what kinds of distortions there are, but not how each one is done. Could you use the census map in relation? These are good questions. Could you use the census map in relation to where to put a business? Yes, absolutely. That's why we use the census maps. We use them to determine where we might need to build more schools. And we use it not at the county level, but we use it, the census data at the block level to determine, like, if we have a whole bunch of young children in an area, we might need more elementary schools. Or if we don't have any young children, we might need to close some down. So what kinds of restaurants or daycare facilities, or do we need housing for independent living for older folks, that kind of thing? Yes. What other than Germany, what countries are at stage 5 in the demographic? Okay, well, we got to be careful with the stage 5 concept, but Japan is your answer there. Japan would fall into that stage 5. In fact, Japan is actually classic stage 5. There's some issues with Germany. Belgium's government, no, Belgium is still it's not a devolution. Belgium's still one country. You have those factors that I explained yesterday could lead to devolution, but they've solved it civilly. They have representation, so no. I would not do not connect. Question is, can we connect von Thunen's model to question A? No, don't. It's least cost theory. Are Are there other bulk gaining industries associated with corn other than ethanol? Livestock, raising. The reason Iowa and Ohio and parts of Michigan and Illinois and Kansas and Nebraska, all of that was all right there on top of them is because that's where they grow corn. They also have cattle, they have dairy farms, and then they also have one of the largest pig producing areas in the country. Listen to the news. With the COVID virus, they've had to close down some of these slaughter plants. Those slaughter plants are there in those small towns near where they are raising that livestock. Why are they raising that livestock? Because that's where they grow corn. And if they're not growing corn, they're growing soybeans, and soybeans and corn are both used to feed livestock. So livestock are an example of an industry that is located near the source of the material. If our teacher didn't go over units 6 and 7, do we still need to do the FRQs about those units? You need to be prepared for unit 6 and 7. So Ms. Brandt and I went over unit 6 and 7 for you. So save yourself some time and go watch the videos with Same Us, and we will have explained unit 6 and 7 to you. So guys, I'm going to need to stop here as I am running out of the allocated time. And those questions I haven't answered, I will answer offline here in just a few moments. So you guys did great today with those questions. They were all right on target. You're thinking great. I love you the way you're thinking. You are going to ace this, and I am so proud of you all. And I hope some of my kids are watching, but I have a feeling they're going to watch the reruns. All right. So once again, contact College Board, cb.org/tech if you need electronic devices to help run with everything for the AP exam. And thanks for watching. Take care. Go out and see the geography around us. Start thinking. Those were great questions, y'all. And have a great night. Bye-bye.